Okay, so I'm going to take a focus back on to trigonometry, and what we're going to start off by looking at first up is a new way to measure angles within a circle. So let's start off with a circle like thus. Now, the size of any angle in the radians is defined as the ratio between two lengths in a circle. So those two lengths are the arc length and the radius. So our arc length is this length along here, okay? So part of the circumference, and our radius, as we know, is from the center to the edge. So let's call that O, A, and B. Now, the size of angle AOB in radians is the ratio of the arc length, AB, and the radius, OA. So what we can say is we can say the size of AB, or angle AB, is equal to sorry, let me rephrase that. The size of angle AOB is equal to the length of AB over the length of OA, or OB, of course, because they're both radiuses. So this definition gives the same angle size, whether the radius of the circle, because all circles are similar to one another. So it doesn't matter if the radius is equal to 5 or 10, okay, because the arc length will change in the rate at which the radius does as well. So what we can do is we can have a look then at the or the particular angle. We can have a look at the arc subtended by a revolution. So let's say we have a circle, okay, and the radius of that circle comes out like this. Okay, so like this. So from the center towards the outside, and we're essentially measuring the whole length, okay, like that. So one revolution. So one revolution, okay, one revolution is equal to the circumference. Hang on, I'm going to move this. Circumference. Okay, because that's the arc length in this case, is the whole around. So it's from this point here all the way around to that point back there. Okay, and it's over the radius again. Okay, so the radius is R. Okay, so by substituting the circumference, so 2 pi R and the radius R, okay, what happens is the two radiuses cancel out, and we're left with the value that one revolution is equal to 2 pi. So in radians, we are referring to. So in radians, if we ever want to measure a full circle, so the angle of a full circle in radians is 2 pi. So that gives us, or lets us down to our first of our basic conversions, which is 360 degrees of a circle is equal to 2 pi in radians. Now on your calculator, what you want to do is you want to hit you want to hit Shift and Setup, and we're going to be using the 4 for radians. So this is why we say you need to be very careful in years 8, 9, and 10 when you start, or years 9 and 10 when you're doing trigonometry, because if your calculator is in radians, it will give you an answer that's not going to give you a degree answer. But if I put 360 degrees, okay, into that, sorry, not 360 degrees. If I put in, let's say, I think 360. No, okay, it doesn't work like that. But you know, if we put in our trigonometric ratios of 360, so like sine, for example, of 360. So sine of 360, we know, so sine of 0 degrees is equal to 1. So sine of 360 should be equal to this. No, it's all right. Anyway, ignore that. It's really bad. Anyway, 360 degrees is equal to pi. Anyway, 2 pi, as I said. So that's what that one is there. Now, this, if we were to half the angle that we were measuring, so if we were to go from the center to the edge, and we would measure completely to the other side, so we were to only measure from here around to here. Okay, so if that was drawn better, it's a really bad one. So essentially diameter. Okay, so in this case, the straight angle is the circumference over the radius again. Okay, now the circumference, well, that's half of the full circumference, so 180 degrees, so half of 2 pi r, so it's just pi r over r. And again, those radii are going to cancel out, and so that's going to leave us with that is equal to pi. So 180 degrees in radians is equivalent to pi, okay? And of course, if you want to do a right angle, or at 90 degrees of a circle, okay, again, 90 degrees is only half of the circle. It's half of the 180 degrees. So if we've got r and r here, and this is the angle we're doing here, so again, it's going to be your circumference of the arc length over the radius, and in this case, it is a half, or I should say, I should do it like this. So it's a half pi r over r, and again, those radiuses are going to cancel out, so the r and r are gone, and so that leaves us with a half pi, or pi on 2. Okay? So this leaves us with the 360 degrees is equal to 2 pi, 180 degrees is equal to pi, and 90 degrees is equal to pi on 2. Now, we can use this to do any generalizations of any value, okay? But, of any degrees or any angle, but these are just the 3 main ones that we know. We also know our exact value ones, so our 30 degrees, 60 degrees, and 45 degrees. So 45 degrees, well, it's half of pi on 2, so it's pi on 4. Okay, 30 degrees is halfway. So 30 degrees and 60 degrees are a little bit different. Okay, so if you think of the 90 degree one that we have, so it's pi on 2, then we want to split it up into thirds. So 30 degrees is going to be pi on 6, and 60 degrees is pi on 3. Okay, so pi on 6 and pi on 3. Now these 3 are very useful for when we do exact values in radians, because you will need to know those ones, because remember our exact triangles, such as our 1, 2, root 3 triangle, okay? So that's 30 degree, wrong way around. That's 60 degrees, and that's 30 degrees. And we also have our equilateral one, which is 2, oh no, that was the equilateral one, whoopsies. I meant the isosceles one, which is 1, 1, and root 2, which is our 45 degree root triangle. So you'll need to know that these trig ratios in a bit as well. So if we want to do our main converting, in this case, to convert from radians to degrees, okay, it's pretty easy. So radian to degrees, we're going to multiply by 180 degrees on pi. And then to go backwards, of course, so degrees to radians, we're going to divide by 180 degrees on pi, or times by pi on 180, whichever way you can see it. Okay, and of course, 1 radian is approximately equal to, so 1 radian is approximately equal to 180 on pi, which is approximately equal to, not 57 degrees at 18 minutes. And 1 degree is approximately equal to, so pi on 180, which is 0.0175 radians. Okay, so just some conversion rates there. So nothing too hard. Now, 1 radian is the angle subtended at the center of the circle with the arc length equal to the radius. This is about 6 degrees, which makes sense as 1 radian is about 57 degrees. So that is, if you think about 1 radian as the length, or not the length, but when the circumference or the arc length of the circle is the same length as the radius. So when r over r is equal to 1 is 1 radian. Okay, so with that being said, let's have a look at some simple conversions. Ooh. Come on back. Okay, express the angle sizes in radians. So quite simple, we're just going to convert these to radians. So if we're going to convert from degrees to radians, we're going to multiply by pi on 180. So it's going to be 30 times pi on 180 degrees. Okay, so 30 on 180 pi, which is equal to 3 pi on 18. And 3 goes into 18 6 times, so that's pi on 6. And that's like I said before. 30 degrees is equal to pi on 6. So yeah, pretty simple. 300 degrees, okay, again, pretty easy. So so we're going to multiply it by pi on 180, okay, so it's the same as 300 pi on 180, okay. Cancel some zeros, so we get 30 pi on 18. Okay, common factor of these two is 3 as well, or 6. So dividing top and the bottom by 6, we get 5 pi on 3. Okay, so 300 degrees is equal to pi on 3 radians. And we know that's approximately right because 360 degrees is exactly equal to pi on 2, so very close. So another way to do it, also 360 minus 60, where 360 is equal to 2 pi, and 60 is equal to pi on 3. Like that. Okay, part C. 525. So 525. So a little bit trickier this time. So we're going to times that by pi on 180. Okay. So 525 times pi on 180. So just put it straight in. Or we can have a look and see if it simplifies on 180. So 35 on 12. So therefore that's equal to 35 pi on 12. Okay, so we want to usually keep these in exact form too. Okay, so that. And last but not least, D. And D says 61 degrees. So we know 60 degrees is equal to exactly 1 radian, so it's going to be pretty close. So 61 pi on 180 is the exact form, which is approximately equal to, so 61 pi on 180, that's equal to 1.06. Like that. And that's in the rounded form, so this is rounded form. So that's going one way. Now let's go the other way. So express these angles sizes in degree, give exact answers, and then where appropriate, given your answers correct to the nearest degree. So part A says pi on 3. So I'm going to start with pi on 3. And then times that by, you guessed it, 180 on pi. Now the reason why, or way to remember it, is that we want the pi's on the opposites because they're going to cancel out. And we're going to be left with 180 on 3, which is equal to 60 degrees. So there you go. Pi on 3 is equal to 60 degrees. Nice and easy. 0.7, so just 0.7. So 0.7 times 180 on pi. Okay, so 0.7 times 180, so 0.7 times 180, that's equal to 126. So this is 126 on pi, which is equal to, or approximately equal to, 40.10. Okay, and we know that this is the case. Well, it's going to be approximately equal to that because 0.7 radians, so 0.7 radians is close to 1 radian, okay, but not quite. And we know that 1 radian is equal to 60 degrees, so for that to be equal to 40 degrees, it sounds about right. So like that kind of sounds approximately right. So we know we're probably right in that regard. 5 pi on 4 is our next one. So 5 pi on 4. And that's equal to, well, what we're going to do is we're going to times it by 180 on pi. Okay, just like that. So again, the pi and the pi is going to cancel out. And we're going to get 180 divided by 4. So that's the same as 9 on 2. So, or 90 on 2, I should say. So 5 is the same as 5 times 90 on 2. And which is the same as 45. So 5 times 45, which is also equal to so 450, so 220 degrees, like that. And that makes sense too, because we know that, okay, so pi is equal to 180 degrees, okay, and if we add, oh no, not 220, it should be 210. No, it should be 225. That makes more sense. Yeah, half of 250. Or 450 is 225. That makes more sense. And if we add 45 degrees, which makes more sense as well, we get 225 degrees. So pi is equal to 180 degrees, so plus 45. Well, I should say we should add, if we add 45 degrees to it, we get 225 degrees, or we also get pi plus, and the 45 degrees was pi on 4. Okay, which is the same as 4 pi on 4 plus pi on 4, which is equal to 5 pi on 4, like that. Okay. Last one is part D. So part D, we've got 25, so just 25 flat. Okay, so again, we're just going to times this one by 180 on pi. Okay, 180 on pi. And so 25 times 180 on pi, well, it's not very nice, so 180 times 25 is equal to 4,500 on pi, which is equal to, so 25 radians is quite a bit, as you could imagine. So if we divide that by pi, we get 1,432, and that's degrees. And 30 or 23 minutes. 24 it should say. 24 it should say. Okay, there we go. So that's some conversion of radians, and that's what we're going to do in this first bit. So next bit, we're going to look at what it actually means, or to evaluate some trigonometric special functions, so or angles that we did before. Okay, so with that being said, that's the end of this one, and I'll talk to you in the next one.